Sup, internet? This truck right here, we could represent its vector velocity, a vector, right? We could represent its velocity as a vector. And a vector is a quantity or an entity or a thing that exists. What I mean is a thing
with both direction and magnitude.
Oh yeah. All right, so this vector quantity has direction and magnitude, which is opposed to a thing like a scalar. A scalar just has a magnitude. So it's only talking about how much, like for instance, how many jelly beans are in a jar, or what time is it. But a vector could represent something like velocity, as we saw with that Ram truck going through, or a vector could be just a displacement. It could be just a delta x kind of thing. And vectors can also be forces. So there's a lot of physics that's represented with vectors, several other examples of vectors I can think of, but I don't want to bore you right now. We can picture a vector in our heads as an arrow. So like this could represent a vector, and I'll tell you why, because this arrow has both direction and magnitude, and it is, well, going a certain direction and also has a certain length that could represent its magnitude. But really this is just a representation of a vector. The true vector, much like a platonic form of a triangle, for instance, a triangle cannot actually exist, but you can picture one in your head. So really that's the only place that a true triangle can exist, which is inside the human mind. A vector is sort of the same way, but we can draw vectors and we can pretend that they represent the vectors in the same way as this represents some number that you don't know. You know, it is a placeholder for a number, and this is a representation for the vector. But I wanted to help you draw a bunch of vectors, because this is usually a struggle for my students. So I'm assuming that you kind of know what vectors are, and I want to give you some challenges for drawing vectors. So the first one is 17 meters due east. In order to draw a vector that's 17 meters due east, I need to determine which way I'm going to declare as east. And I probably want to determine another direction too, like maybe I will declare east to be that way and north to be that way, like I'm looking at a map or Google Map on my phone or something, and it looks like that. And so this is my coordinate system, and the coordinate system tells me what's up in the problem. Get it? What's up? Yeah. The coordinate system tells me what's up in the problem, and if I need a vector that's 17 meters due east, I would probably draw it an awful lot like that. And I will name that vector A, is a vector pointing directly to the east, and there it is. So let's do another problem. This next problem is a little bit more fun. What about this guy, which is supposed to be 12 meters directly, see that, directly southeast? And if I saw, ooh, directly southeast, could I use my same coordinate system? Yeah, let's make another coordinate system that looks like that. I'm gonna put north that way and east that way. Sometimes people are sometimes people are excited about like drawing south instead. If you really need to, then you can show south as that way, but I'd be fine just showing north and east right there. And then I'd take my purple and I'd go, well, directly southeast? Ooh, that's in between south and east, so that's like that. And I'll point out, well, we can call this vector B. I'll point out that this angle here between east, that's the east direction that I'm dotting right there, and my vector, that angle is probably 45 degrees. So now I've really carefully specified that, and we can work with that vector because it's directly southeast. But here's another problem. What if I gave you a challenge where it was like 6 meters, ew! What if I gave you a problem where it was like 6 meters per second, because velocity can be a vector as well, and I said at sorry, that's how I draw my at symbols, at 13 degrees up from north. So here's the first thing. You may think that you can draw yourself a nice coordinate system, and your coordinate system is going to show north and east like it did before, but wait a second, which way is up? So my students struggle with this for a long time because they try to think about up and north as being the same direction, right? Oh no, are up and north the same direction? So I want you to take a break right now. Let's go ahead and pause this sucker. I want you, as soon as I say pause, I want you to try to point your hand north and point your other hand up. Can you do it? And pause. Were they pointing the same direction? Were they? Were they? Were they? All right, so here's the problem. If I specify up and north as the same direction, then I've got a disaster here. But I think that up and north are actually at right angles to each other. So a lot of people use the word perpendicular, but that has a lot of syllables, so I prefer the word normal. Up and north are normal to each other. So here's the sitch. I'm gonna draw up as actually up on my paper, and I'm gonna draw north like this. If you take your phone or computer screen and lift it up now, you can actually get it so that this up arrow is pointing straight up in your real world. Are you guys real? I don't even know if you're real. And this one is pointing north in your real world. Find out which way north is. You know the sun rises in the east. Come on, figure it out. It's not that cloudy, England. Get out. Up, north, right angles to each other, and I need to specify a vector that is 13 degrees up from north. And sometimes that's a challenge also. Let me show you where people struggle on this. 13 degrees up from north. They'd be like, well, is it 13 degrees up from north like that? Or is it 13 degrees up from north like that? Is this 13 degrees up from north, or is that 13 degrees up from north? So you can either shout this or that at your computer right now. Go. Is it this or is it that? Go. Well, I suppose you want me to tell you. I'm not going to tell you. All right, let's go to the next one. Here's the next problem. This problem is 4 n's, whatever the heck an n is, and it is at an angle of 59 degrees west of south. Can we do that? Now, in this case, I'm probably going to make a coordinate system that's the traditional way, where I'm putting north here and east here, and I need to go west of south. So what I do in order to do this is I think about south, and I need to be 59 degrees west of it. Now, if I were 0 degrees, this is the way to think about it. If I were 0 degrees west of south, that would be like south, right? This is 0 degrees west of south, or is it? No, that's entirely wrong. If I were 0 degrees west of south, this would be. Isn't that 0 degrees west of south? Well, it's not west of south at all. I guess it's the same thing as 0 degrees east of south. Yep. But if it's 59 degrees west of south, I've got to start by considering the south and then going 59 degrees west of the south. So I'm looking south, I'm starting from here and looking south, but I'm supposed to go west by more than 45 degrees. So I'm going to emphasize that like this. There's my vector. I should probably call this vector E or something. Vector E is 59 degrees west of south. There it is, 59 degrees west of south. Should we do one more? Let's do one more. Okay, we'll probably do 2 more. Here's the next problem. The next problem starts out like this. It's like 200 kilometers at 35 degrees left of forward. Oh man, how confusing is that? Left is an arbitrary designation, and every time I turn, it turns with me. And wait a second, so is forward. That's actually pretty good news. If we have 2 arbitrary designations, we can work with them. Because I'm thinking I could draw forward like this. Do you want to put left over here? Sometimes I still put left over there. It's pretty funny. I'm going to put right over here, because that is right of forward. So left of forward is going to be that direction, and I don't need to draw it. You might want to draw it, but you don't need to draw it. And then I'll say left of forward. So that starts by considering forward. There's forward, but I'm supposed to go left of forward, boop, by 35 degrees, like that. So that is the angle, 35 degrees, and this is 200 km. Excuse me. So, we've been drawing vectors for a long time. You guys want to do a different one? Let's do one final vector. What do we call this? Vector F? Awesome. So let's do vector G. G, here we go. Vector G, vector G. I'm making this up on the fly. Vector G is supposed to be 16 meters at 230 degrees clockwise from negative y. Oh my goodness. Can you draw such a vector? First of all, you want to just establish x and y in the traditional way. You be like y and x, like that. And then you draw negative y. Here's negative y, dot, 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 dot. Is that negative y? No, that's negative x. Okay, here's negative y. And then I'm supposed to be 230 degrees clockwise from it. Now clockwise is like a clock goes. Clockwise is that direction. So this is 90 degrees clockwise. This is 180 degrees clockwise. This would be 270 degrees clockwise. That's too far. So consider me this. If I've gone around like this, like 90, 180, I've got 50 more degrees to go. I'd be like dot, 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 50 right there. 50 degrees, and this is 16 meters. So that is a crazy vector that's 230 degrees clockwise from negative y. I could also say, this is vector G, I could also say that G equals 16 meters at, well, I could also say it's at 40 degrees counterclockwise from x. That would be a much more standard way to specify the direction and magnitude of G. Remember, in all of our vectors, we're going to have to specify magnitude and direction, and that's all I have to say about that. Or just has a magnitude. So it's only talking about how much, like for instance, how many jelly beans are in a jar, or what time is it. But a vector could represent something like velocity, as we saw with that Ram truck going through, or a vector could be just a displacement. It could be just a delta x kind of thing. And vectors can also be forces. So there's a lot of physics that's represented with vectors, several other examples of vectors I can think of, but I don't want to bore you right now. We can picture a vector in our heads as an arrow. So like this could represent a vector, and I'll tell you why, because this arrow has both direction and magnitude, and it is, well, going a certain direction and also has a certain length that could represent its magnitude. But really exists, what I mean is a thing
with both direction and magnitude.
Oh, yeah. All right, so this vector quantity has direction and magnitude, which is opposed to a thing like a scalar. Sup, Internet? This truck right here, we could represent its vector velocity, a vector, right? We could represent its velocity as a vector. And a vector is a quantity or an entity or a thing that exists.